this graph to the far right of the screen, it has the end behavior of an even degree polynomial because both the ends go down. If both the ends go down or up, we have an even degree polynomial. And it has 1, 2 zeros of multiplicity 1 and 1 zero of multiplicity 2. And I know it's multiplicity 2 because it bounces off the x-axis. So I'm just going to list these here. My zeros are at x equals -1, 0, and this one has multiplicity 2, and 2. Alright, so now I can write out, since I know the zeros, and there are 4 of them, I'm going to use a 4th degree polynomial to model this thing. 4 zeros, 3 extrema, it's got to be 4th degree. So I'm going to have y equals a times my 4 factors, 1 for each 0. And they're all going to be x minus, x minus, x minus, x minus, and then I put in the zeros. So I have -1. 0 goes in twice because it has multiplicity 2 and 2. Alright, so to figure out what A is, I just have to pick any other point on the graph that goes through a nice grid point. Maybe this one here at 1, 2. 1, 2. So replace y with a 2 and x with a 1. And now I just have to solve for A. So I get 2 equals A times 2 times 1 times 1 is 2 times -1 is -2. So A has to be -1. And that actually makes sense because our end behavior with the both ends going down means that we need to have a negative leading coefficient. So -1 seems to make sense. So my final equation is going to be this guy, simplified a little bit, and with an A is -1. So it will be y equals -1 times x plus 1 times x squared times x minus 2. And again, there's no need to multiply that all out, just leave it in factored form.